Hello students, today we are going to learn application of logic to switching circuits. We shall study how the theory of logic can be applied in switching network. We have seen that a logical statement can be either true or false. That is, it can have truth value either true or false, that is T or F. A similar situation exists in various electrical devices. For example, an electric switch can be either off or on. In an electric circuit, switches are connected by wires. If the switch is on, it allows the electric current to pass through it, and if the switch is off, it does not allow the electric current to pass through it. We now define the term switch as follows. So a switch is a two-state device used to control the flow of current in a circuit. We shall denote the switches by the letters S, S1, S2, S3 and so on etc. Now see here, one circuit diagram is given. Here we have switch which is denoted by S, then battery and lamp is denoted by L. We consider a circuit containing an electric lamp L controlled by a switch S. When the switch S is closed, that is on, then the current flows in this device or circuit and hence the lamp glows. Whereas when the switch S is open, means off, then the current does not flow in the circuit and subsequently the lamp does not glow. Now here we have two switches in series. See, circuit diagram is given and containing two switches S1 and S2. Here we have battery and L denotes the lamp. Now these two switches are connected in series. So while writing the symbolic form, we will write let P denotes the switch S1 is closed. Then Q denotes the switch S2 is closed. Since here we have given only two switches, we will consider P and Q. If the switch S3 is present, then we will consider R for that switch S3. Now L, the lamp is on. The symbolic form is given by P and Q. So whenever two switches are connected in series, then we consider the logical connective AND. Now if we want to write the input output table, that is also called as switching table, then our first column will be P, second column will be Q, and here we want P and Q. Now as while constructing the truth table, we consider the possibilities T and F. Similarly, while constructing the input output table, we consider the possibilities 1 and 0. So here the possibilities for P will be 1 1 0 0 and the possibilities for Q will be 1 0 1 0. Now do you remember the table for the logical connective AND? Out of two statements, any one is false, then answer is false. So here out of these two, if any one is 0, then you will get the output as 0, otherwise you will get the 1. So here we have 1, then 0 0 0. Now second case, two switches are connected in parallel. Now see, circuit diagram is given containing two switches S1 and S2. These two switches are connected in parallel. Here we have battery and L denotes the lamp. Since here also we have given only two switches S1 and S2, we will consider P and Q. So P denotes the switch S1 is closed. Q denotes the switch S2 is closed. And L is the lamp is on. Now here the symbolic form is P or Q. Means whenever the two switches are connected in parallel, then we consider the logical connective OR. So here we have symbolic form as P or Q. Now while constructing the input output table, that is switching table, our columns will be P, Q, P or Q. Now here also we will consider the possibilities for P as 1 1 0 0, then the possibilities for Q as 1 0 1 0. Now do you remember the table for the logical connective OR? Out of two statement, any one is true, then the answer is true. That means here out of two possibilities, if anywhere you have given 1, then answer is 1, otherwise 0. So here we have 1 and here we have 0. So next we will consider the questions. First one, express the following circuits in this symbolic form of logic and write the input output table. Now here this circuit diagram is given where S1 and S2 are connected in parallel and these two switches again connected in parallel with S1 dash and S2 dash, and this S1 dash and S2 dash are connected in series. Now first we need to write the symbolic form for this circuits and then we will construct the input output table. Now since here also only two switches are present, we will consider P and Q. So let P as the switch S1 is closed, Q as the switch S2 is closed. Then since S1 dash and S2 dash are also present, here we will consider negation of P, the switch S1 dash is closed, negation of Q, the switch S2 dash is closed. Otherwise we can write like this, negation of P, the switch S1 is open, and negation of Q, the switch S2 is open. Anyway you can write for these two, negation of P and negation of Q. Then L, the lamp L is on. Now here the symbolic form is given by, since these two switches are connected in parallel, first we will write P or Q, then these two switches are connected in series. Here we will write negation of P and negation of Q. Since they are connected in series, we will consider the logical connective AND. Now these two together are connected with these two in parallel. So again here in the middle we will write OR. So this is the symbolic form for the given circuit. Now input output table, or we can say switching table. First we will write the required columns. So first column is P, Q, then negation of P, negation of Q, then P or Q, negation of P and negation of Q, and finally the last column will be the entire symbolic form, that is P or Q or negation of P and negation of Q. Here we will consider the possibilities for P 1 1 0 0, then possibilities for Q 1 0 1 0. Now negation of P will be 0 0 1 1, negation of Q 0 1 0 1. Now P or Q, out of these two any one is 1, then answer is 1. So 1 1 1 and 0. Now negation of P and negation of Q, we will consider these two columns. If any of the value is 0, then answer is 0, otherwise answer is 1. Now finally we will consider the logical connective OR for these two. So out of both the possibilities, anywhere if we have 1, then here we can write 1. So finally we are getting 1 everywhere. Now considering the one more question, this circuit is given. Here we have S1, S2, S2, then S2 dash and S1 dash. So first we will write this part as P, the switch S1 is closed, Q, the switch S2 is closed, then negation of P, the switch S1 dash is closed, negation of Q, the switch S2 dash is closed, and L, the lamp is on. Now the symbolic form is given by, since these two switches are connected in parallel, first we will write P or Q, then these two switches are connected in parallel, so here we will write negation of Q or negation of P. Then these two are connected here middle with S2 in series, so here we will write AND, Q, AND. So this is the symbolic form for given circuit. Now while constructing the input output table, first we will write the required columns. So first column is P, then Q, then negation of P, negation of Q, then we require P or Q, negation of Q or negation of P, and finally the entire statement. Here at a time we can write all three statements because at both the places we have the same logical connective AND. So possibilities for P 1100, possibilities for Q 1010, then negation of P 0011, negation of Q 0101, then P or Q, we can apply logical connective OR here, we will get 1110. Then for these two statements again we will apply the logical connective OR, we will get 0111. Now for these three columns 1, 2 and 3 we will apply the logical connective AND. Means out of two possibilities, anywhere if we have 0, then the answer is 0. So 0, 0, 1, 0. So this is the input output table for the given circuit. Thank you students.